Hi folks, I'm Tom Affolter and this is my third module on Transact SQL Basics. You should recall for a programming language to be a programming language, there are some common features it has to possess. It has to have the ability for input, it has to have output, memory storage, it's got to be able to do math, and it also has to have the ability to do looping structures and conditional statements. This was a big leap for ANSI SQL. In this module, we're going to take a look at Transact SQL Logic structures, selection structures, and loops. I hope to focus on the logic statements themselves. First of all, we're going to differentiate between the if-then from the inline case statement. We'll talk individually about the if-then-else statement, the case statement. We'll talk a little bit about loops in Transact SQL. We'll step back off topic just for a couple of minutes and take a look at the at row count. That's a system variable that has some advantages for us. We'll review the in statement. We'll take a look at exists and how that can benefit us. And then we're going to close out by taking a look at the print statement. In Transact SQL, there are two distinctly different types of conditional logic. Case statements, which run inline as a clause, typically in a select, can also be used in an insert, an update, or a delete statement. We have the if-then-else statements, which evaluate the results of a select or a set statement. Inline case statements run at the row level and can reference any field in that row. Case statements can be as simple as converting a coded abbreviation such as NSEW into north, south, east, or west, to as complicated as using a join type statement within the case statement to look information up. Case is extremely flexible and very powerful. If-then statements are powerful as well, but their use differs. Typically, you'll copy the results of a select into a variable and then use an if-then to evaluate those results. It doesn't run at the row level like a case statement does. I use both, but I definitely use case statements about 10 to 1 over if-then statements. The structure of a SQL statement is very similar to Visual Basics in the form of the if-then statement. Like Visual Basic and unlike C#, the comparison operator for testing equality is the single equal sign rather than C#'s double equal. If there's a single statement within the if or else regions, nothing needs to be done. But if you need to perform multiple statements in the then or else portions, you'll need a block, just like Visual Basic or C#. The major difference between Visual Basic or C# formats for that matter is that logic can be direct results from a select statement. Also, a major difference is that VB requires that then phrase. Transact SQL doesn't accept the then statement. The then is implied. In this example, if the result of the select statement is greater than or equal to 100, the statement prints out that you have 100 or more members. But if a false is returned from the logic, that means that there's less than 100 members, then the opposite statement is displayed. Now take a look at what we have on the screen here. Rather than copying the information into a variable and using the if statement to look at the variable, we're actually applying the select statement directly to the if statement. But if there are more than one statement within the then or the else portion of the if logic, then we need to use a begin and end statement, as you can see here. Now these will be the equivalent of the brackets within the if logic on C#. As advanced programmers, you should by this point understand the idea of the logic and how to formulate an if statement. Let's look at this example. Here we declare an integer variable which is at renewals. We then count the number of null and expired renewals in a select into the at renewals variable. Then we use an if to determine if the renewals are 0. If such is the case, we post no renewals on the screen or in the data set, and then we remove the renewal table. But the else portion reads, else we use the case method we discussed in Module 2 to cast the renewals into a string that might say something like 10 renewals to update. We then copy all the expired renewals into a renewals table. So here's an example of our first if-then, and I've gone ahead and typed out in advance, and let's take a look at what it's doing right here. Now I'm passing into it a player ID, so I'm declaring the variable right off the bat, and then I pass in this Adams WI02. That's because I'm doing a script right now. I could have this as a store procedure, and I could be passing that in as a parameter in the store procedure, but just to keep testing it out, I chose to go ahead and leave it the way it is. So I also declare a variable I'm going to hold a full name in, and then I create another variable that I'm declaring and going to holding the player's batting information. So down here, what I'm doing is I'm grabbing out one complete statement, and in this statement right here, I'm grabbing out the first and the last name concatenated together as @name, and then I'm grabbing out the player's batting, whether they bat right, left, or both, as @bats. And the way that I know which player, because the if-then-else statement has to return only one value back for each variable. If I had multiple values coming back, this would not work. So I need to tell it which player to grab, and I'm passing in this Adams right here at player ID. So the first thing I have to consider is what happens if this player ID does not exist and somebody typed it in incorrectly. So that's the very first thing I test in my if statement is if the @name is null, then let's pass back that the player ID was not found, because we can't even give a name if there's no player ID. But if it makes it past this portion, then we know that the player exists. So if it returns back an L up here for bats, then we're going to put out that player's name, bats left-handed. Else, if it's an R, now notice what I'm doing here. It's an else-if statement, very similar to what you would find in C# or Visual Basic. So I don't have to have an end-if for every statement here. I'm going to have basically one end-if, and you don't have an end-if per se in the in Transact SQL, but we have that same concept. So I want this logic, all three of these examples, to be completed in an if. I have to do that. I only have two different possibilities in if then else. So first thing is, does the name not exist? If it doesn't, tell them that. But if it does exist, then print out the name if they're left-handed, and tell them that they bat left-handed. Else, if they bat right-handed, if there's an R in that column, then print out that person's name that they bat right-handed. Else here at the bottom, they obviously then, if it's not null and they don't bat left and they don't bat right, they have to be switch hitters, so bat both. So that's what I'm going to do. They bat both right and left, because that would mean then that there has to be a B column or a B in that respective column out there. So let's go ahead and test this out, and here's the result of that first one. I have some more column player IDs over here, so let's just randomly grab one out of here. Do a right click, copy that data, come back over here, and I'm going to go ahead and paste right here. And that's the case. Let's run it and see who we got here. Oh, taking a little bit longer to run. Gerald Alexander bats right-handed. Let's put one in here that doesn't work. We know that that name doesn't exist here. Let's execute it. And it tells me that this person is not found, that there is, and the Alexia is what it thinks the player ID is. Now again, notice after each one of the ifs that I have a single statement in here. Had I had another statement, let's just temporarily put one in here, something like select, we'll just do, it can be anything here. Let's select that player ID. If I go ahead and I try to execute this, and I want to, let's just go ahead and parse it, I'm going to get an error here, and the reason is that I have two statements following this if, and it sees only this first statement as belonging to the if, and it says, I don't know what the rest of this down here means. If this was going to be the case, I would have to put in here a begin and an end statement here, just to point out that those statements all enclose now in this if portion of it. So hopefully this makes sense. Let's go ahead and continue on. So let's try a demo. Let's create a store procedure around a master batting join that receives a team ID parameter. Let's start by calculating the average of all the 2004 players. We're going to return an @average, underweight, or overweight, depending upon how the past team parameter that team compares, their average compares to the overall average weight. So this time I think I'm going to go ahead and create this store procedure by hand. So I've started up SQL Server, I'm in Management Studio, and I have got baseball, in this case baseball 2014, database active. So I'm going to go ahead and create proc, and I'm going to go ahead and call it, let's call it compare team weight. So SP compare team weight. It's going to have one argument coming in, so I'm going to pass into it a team ID, and I think that team ID is going to be a varchar 10. That should give me plenty of characters. I believe I only need 5. And now I'm going to create the statement as. Now I'm going to need a variable on the inside, because what I want to do is calculate the average and then store the overall average into this variable, and it's going to be the variable I use as a comparison. So let's go ahead and declare a variable, and I'm going to call it @average, and that's going to be of type integer. Now I'm going to select into @average the average weight from, and previously we created a view inside baseball, and let's go back and take a look at that real quickly here. Here's all my tables. Let me close that out. Here's my views, and I have a join between master and batting. So the master table joined to the batting table. We did this back in a 126 class. That way I can pull out all of the batting information and the team information. Now, of course, this only includes those players that batted. So I'm going to use that particular view to pull information up, because that's where the team ID is once information is joined. So VW master batting, and then I want it to be where at least in this particular case, the year ID is equal to 2004. I believe those were the specifications on it. Make this more flexible. I might otherwise want to pass the year in along with the team ID, but that's not what was called for at this time. So the next thing I want to do is I have calculated at that point what the average is. Now I want to go back in and get the team weight of the particular team that I pass in. So let's store that to another variable, and we'll call this the @team weight variable, I guess. So let's declare @team weight. That's going to be an integer as well. And now we're going to do pretty much the same thing that we did up above here. In fact, I'm going to go ahead and copy this code right here. Try that again. Paste it down here, but this time I want this to be team weight. I want it to be for 2004, but I also want it where the team ID is equal to, and that would be the passed in team ID. There we go. So now by the time I get to this point, up here I will have calculated the overall average for that respective year, and then down here I will calculate the average weight of the team for that respective year that we're going to compare. And now the next thing I need to do is have an if then else statement to determine the difference. So let's do something like this. Let's see. If the team weight is greater than the average of the team weight, then what I'd like to do is, I guess we'll just put a simple statement back up on the screen here and say that the team, and we'll put a space, and then we'll concatenate into that the team ID name. So we spell that out. So we've got team ID, there we go, telesense, is greater than the overall average. So what I'm doing here is now I'm looking to say, once we've calculated those two, is the team weight greater than the average weight, in this case, of all baseball for 2004? If it is, then say that back to the screen. The team weight is greater. Else, what we would like to do, let me clean this up, is the exact opposite. We'll just go ahead and copy this out, and we'll paste this in right here. And let's see, and then I need to change this to less than, and of course I have to give it a column header in both cases, so let's do a weight compare. And I believe that we're in pretty good shape here. Let's go ahead and check it out, parse it. It says the parse worked. Let's go ahead and execute it and build it. So I misspelled varchar somewhere. I'm surprised that parsing didn't get it right there. Okay, let's try that again. Reparse, re-execute. That time we worked out. So now let's take and try a couple of teams here. And before I go on, I want to point out that this time I chose to use the DBO dot. It's probably a pretty good idea to get in the habit of doing it. Not a big deal if you're a single user on a database and you have all of your data in that one schema, but if you're using multiple schemas, then you're going to want to mention at the beginning of all your statements what that schema is. And right now it's DBO as default. It will tend to speed up your applications as we go along. So let me go ahead and copy this guy right here. In fact, might as well execute it with the whole statement. Let's open up a new query. And paste that in here. And let's see, what team do we want? Let's start off with the Mariners and see how they compare. Execute. It says Seattle, Team Seattle is greater than the overall average. Let's try a couple others here. Let's try Pittsburgh. See how they check out. Pittsburgh is less than the overall average. Now, of course, we could have displayed the average back with it, but the whole purpose was to return back a statement that we would gather on the program on the other end. So going back and looking at the code again, a couple of things I could have done here to work as a shortcut. For example, I really didn't have to deal with variables here. What I could have done is, rather than put this variable in, I could have taken that entire statement, the entire statement that was produced, and placed a statement inside here and do the comparison that way, and with both of them. So I really could have eliminated most of this code, but that certainly would have made this area a little bit more complicated looking, and I like the way it looks right now. It's pretty clean and easy to understand. Let's continue. The case statement is logic like the if-then, but case is run inline at the row level, whereas if-then runs as a result of a select statement or perhaps a parameter that's passed in. If-thens are embedded in scripts, stored procedures, or functions. Case statements can be embedded in a simple select. Both are powerful, but again, I tend to use the case statement more often. We call it inline again because it replaces a column within the select statement. In other languages, it's called an implied if. You can use the case in most portions of a select, including the where or the order by clauses. Let's start off by looking at a couple of different examples of the case statement. In this first example, you'll see that we're replacing a case statement, or we are placing a case statement within a select as though it was a column. In this particular example, we have either a column or perhaps a formula that we want to evaluate the results of. So we start off with case and what we want to evaluate. Now, based on the evaluation, it's going to come back with a result. That's what we're going to be looking at within the when portion of it. So when the result of the evaluate statement comes back, then we want to have a result come back out of it. So it's very similar to the basic case statement that we might otherwise use. And notice that we've got a case else statement at the bottom, and that is when all the case statements produce a false, then it falls back into the else only if the else exists. And also, take a look at the very bottom of this. We have an end and then a column name. So the case starts off with the case start and an end at the bottom, but we always have to provide a column name on a case statement, just as a formula does. Here's an example that we'll take a look at real time here in a moment of a case statement where we're evaluating a particular field. So we're selecting name, and then we're taking a look at the type member field. And if the type member field has an F in it, so this is the encoded example that I talked about earlier. So we may not want to store the entire word family or regular, but we want to display those back in a select statement. So when the value is an F for type member, we want to display back the word family. Else, when it's an R, regular, and we know that if we've only got 3 different possibilities, the last possibility will be life, so we'll close that out. We end the case statement, and then of course we have a type member column header that we're going to place into that. Here's an example of the second type of case statement that we might want to use, and in fact this is a little bit more versatile than the first. Notice here that we don't have a particular field or formula following the case that we're evaluating. In fact, all we have to do is put any logic that produces a true or false in the portion that you see on the slide here where logic exists, and when that logic produces a true, the result is going to be replaced in that particular column. And of course we also have an else statement down below here, and just as before we still have to provide a column name. Here's an example using that particular method we had before, and I could have gone back in and formatted this one with a column because I have sales here as well. So it's showing you how either one of the 2 case statements might be implemented depending upon which one you prefer. Again, going back, I could have said case sales and then evaluated sales down below, but I chose to embed it this time within the logic. So what we've got here is the start of the case statement, and when the sales column exceeds 10,000, then what we want to do is calculate bonus at 10% of the sales. But when the sales are greater than 8,000, then of course what we would like to do is give them an 8%, and then if their sales are greater than 4,000, then we give them 6%. Otherwise, they get no bonus whatsoever. Now, one thing I'd like you to take note out when we're taking a look at this is notice that when one of the logics produces a true, that it will fall all the way down to the end statement. Oftentimes what you'll find is like in the switch statement that C# has, once you complete the logic out, you have to put a break statement that tells it, I'm done with this particular statement, jump all the way to the end. You'll find that the case statement is very similar to Visual Basic in the fact that you do not have to tell it when to conclude. Once one line of logic holds true, it then automatically will jump down to the end statement. So let's go ahead and try an example of this. Using the baseball master table, let's produce output that converts one of the character outputs for batting and throws from R, L, or B, right, left, or both, into something more meaningful like right, left, or both. Let's try it doing a case statement. Okay, we're going to take a look at 2 variations of the case statement. So I'm going to start a new query. Make sure that I'm in the right database. I'm not. I'm going to go to baseball. And inside baseball, let's just take a look at, as long as I'm here, let's jump down here, open up the tables. And in fact, let's look at the views instead. So I've got views, master batting. Let's open this up. Take a look at the top 1,000 rows. So as the data comes back, I want to take a look at one of the columns that we have over here, and that's the bats column. And you'll notice that there's 3 different types of data in the bats column. Typically, we're going to find that if they're right-handed, they have an R. If they're left-handed, they have a L. And then if they're switch hitters, or they can bat both left and right, then we're going to have a B within that column. Now, there's also some unknowns in there. Players that played back in the 1800s, and for whatever reason they didn't record it. So what I'd like to do is I want to use a case statement to come back here and let's simply clarify this bats column as it exists right here. In fact, I can do it right where we're at. So let's go ahead and delete this information out. And what I want to do is select name last, name first, and then after I do this, I want to create a case statement. I want to look at that bats column. So I want to get out, well, in fact, let's just do that right now. Let's do bats, and we'll do from VW master batting. Make sure I've got that. Name last, name first, bats from VW master batting. Let's execute that. And because I've got the wrong database, I thought I had selected it correctly. Let's try that one more time. Back to baseball. Re-execute. And now you'll see how I get the R's in here. And if we thumb down here, L's. And also notice that our data is repeating. And the reason it's repeating is because, in this case, David Ardzima played for 1, 2, 3, well, we can see all the way down here, for 8 separate years, so he's getting 8 different records back. Now, since these rows repeat exactly the same data, I can come back up here and put a distinct and run it, and now I'm going to get the unique rows that come back from master batting when it decides to come back for me. There we go. So here you get a better idea of the different types of data. We've got R, L in here. Also notice that down here we have a null from this Francis Abercrombie. It's a mouthful, Abercrombie. Anyway, we have a null down here, which means we don't know whether he batted left, right, or what have you. So I'm going to go back and modify this column right here, and I want to have it return a little bit more meaningful data, and I really want to get rid of those nulls and put something else in here. So the very first thing I'm going to do is let's move everything down a bit, including the bats here. And it's the bats column I'm going to be playing with. So let's do this. Let's do a case, and we're going to look at bats. And we'll say when bats is an L, we want it to then put the word left in. Very powerful, really cool. This command basically allows us to go back in and do exactly what we do here, and that is put some basic codes in to code information, but when we return it back into the user or back into our programs, we can then extend it out if we need to. It's much easier, by the way, to do it here on the server side than it is to try to turn around and do it on the program side. SQL Server will modify the data much, much faster than you can do on the programming side. So any data that you can convert at the SQL Server side, aside from formatting, you want to do that. So next one is when it's an R, then I want right. When it's both, then I want both. And now I don't even have to ask when it's null. If it's neither an L, an R, or a B, which really should only leave null or even an empty string for that matter, then I'm going to do the else here and say I don't care what else it is. Else, I simply want you to put in unknown. Now, in order to do this, I'm going to go ahead and I have to close it out. So I'm going to put an end statement in here, and that closes the case out, and then I have to give it a column header, and I'm just going to call it bats. It can have the original name that it had before. And let's check this and make sure this is going to work. Parsing says it works, and let's run it. And there we go. You'll see how now what's being returned is right and left, and then notice down here with this Abercrombie, oh, much better that time, I have an unknown on here. So it allows me then to do some data conversion, allows me to convert the nulls, if you will, back into any kind of statement that I want. So it is a pretty powerful statement. Now let's go ahead and take a look at the other variation of the case statement here. And notice again, these are called inline. These are extremely powerful because these are done at the row level, which means as this row ran, it then determined how right fit in. That's the big difference between the if-then-else statements, because the if-then-else would have wanted to take a look at the results that came back from a select and do some kind of comparison on it. And generally, it's outcomes of the entire select based as opposed to from the row level base. So let's go ahead and get rid of this. And this time what I'd like to do is let's go ahead and we're going to go and return all the U.S. players by name, their birth city and their birth state. So let's do that. So let's select, was it name last? We'll do name first. And we'll do, let's see here, birth city. And we'll do birth state. In fact, what we want to do is let's return this back as a single string, and that's really our goal. So let's do something like this. Let's say that we've got birth city. We want to add to that, after the city, a comma, a space, and then we want to add in the birth state. Now, since that's a concatenated field, we have to give it a header, so let's call it birth city state. Something, oops, can't put a slash in there either. So, in fact, let's just call it birth city state. So there's my column, so I want to grab that from master. And let's do VW master batting. Let's go ahead and execute this and see how it's going to work. So far, so good. Oh, and we only want those that are born in the United States, so let's go ahead and add that in while we're at it. From VW master batting, where birth country is equal to USA. Okay. Execute it. Looks pretty good. In fact, it looks like we've got a lot of repeating data in here, and it's exactly the same data, so we can probably get away with a distinct up here. And now let's re-execute it again. And sure enough, we have all the data coming back in, and it all looks right. But in fact, there is a problem with it. And let me give you an example of what the problem is. Let's go back out here and pull up a particular player that I was looking at just a moment ago. And that is, let's see, I want where the birth country is USA, and let's see here, I want player ID is equal to, and I want him to be the BAILEKI01. Let's take a look at this guy right here. If I execute him here, I'm getting a city and state that's null. And that's pretty interesting, city and state that's null. Let's go ahead and extend this out. Let's just take a look at that entire record. So let's do a select star from VW master batting, and then let's use the same where clause. So from there, where, but this time I want to do where the player ID. Let's see what we've got here. Let's run this guy and look across here. And he played a long time ago. In fact, he died in 1917. But one of the challenges that we have is take a look here. Where are we at here? His birth state is Virginia, but he doesn't have a birth city, which I would imagine either they didn't know what it was, or he was born in a farm or out in the country somewhere that wasn't assigned a particular city. One of the problems that we have with SQL is that anytime you apply a null in concatenation, the entire string is a null. I don't care whether you've got 99 different strings that have information in it. You want to plug all those together, and then the 100th piece of data you plug in as a null, that entire string will come back as a null. So a null plus any other string is always going to return a null, and that's the problem that we had with this record up here. Let's run them both and again compare. Notice how we got the null here when we added city and state, but the state was Virginia. So Virginia plus a null equaled the null that we have up here. So what we're going to do is we're going to try to correct that with a case statement, and within that case statement, let's go down here a little bit. What I want to do here is I'm going to replace, I believe, this part. In fact, we'll replace this entire part of the select statement with a case. And I think before I do it there, I'm going to come down below here, and I think I'd like to just write it out in advance, and then we'll go ahead and paste it up there because it'll make more sense doing it this method. So let's do a case when. Now this time we're not doing a case as we did before where we're comparing a statement. This time we're going to apply the logic entirely in the when portion of it. So we're going to, and that is extremely powerful because that means we could do formulas, we could do a variety of different types of logic that we're not tied to a specific field looking at. In this case though, I am looking at a particular field, but I'm going to do a little bit more with it. So I'm going to say when, so case when the birth city is not null. So if it's not null, we just want to do the normal thing. If it's not null, I think then we'll simply say, let's take the birth city that we have up here, and we're going to add that in with a comma and a space after it. So let's try this. So I'm going to copy that. I'm going to paste this down here. So when the birth city is not null, then we just want to put in the regular birth city plus a comma and a space. But in that case that it is null, if it is null, then we're going to go ahead and say else, and let's go ahead and put this down below here. Else, what we want to do is absolutely nothing. We don't want to put a city in. We'd rather just put an empty string in there, and we're going to go ahead and end it at this point. And then we have to continue on by adding in the rest of the state and the city state at the end here. So again, I'm going to go ahead and be lazy. I'm going to copy this. I'm going to paste it right here. And that will be our entire statement that replaces this guy right here. So we're saying when birth city is not a null, then put the birth city in as it exists plus a comma and a space. But if the birth city is a null, it's going to put an empty string in, and afterwards we're going to add back into it, and I'm getting an error here because it's not plugged in. We're going to add back into it the birth state. So birth state's going to be added in regardless of whether or not it's a null or not at the end. In that example that we have down below here, it's simply going to put, if we do it correctly, Virginia in place of the city state. It's going to ignore the fact that there's a null there. So let's go ahead and grab all this code out. Let me go ahead and cut it, and I'm going to paste it right here. And let's check it. It says it worked okay. Let's go ahead and run it. Oh, and before I do that, I want to run it for everybody and not just this guy here. We'll test him in just a moment. So let's highlight this guy first, execute, and in fact, we get all of our city and states back in here. Oh, before I go on, one thing I did want to note is that the very first time when I ran this statement, it did not return any of the null values. It only returned back the fact that this player ID was null when I implicitly said I wanted to see that. So by default, originally the select statement ignored any of those city and states that were returned. But by me adding this in at the end, originally that's what allowed me to look at it. So now we see we've got the statement in here. This guy is actually embedded down below, but let's look at him by himself and see what we end up with. And sure enough, we end up with Virginia. So this should give you a pretty good idea, although I'd really like to format this out a little bit better, about what a case statement would look like. So when cases birth city is not null, then we want birth city plus a space, else we want a space. And let's see here, if I do this correctly, I think that's pretty well formatted. And of course, this can go on and on and on. I can do a variety of different things. Extremely powerful case statements out there inline. In fact, I personally believe they're far more powerful than the if statement. The if statements tend to be embedded in a script, whereas I can put a case statement in any select statement I choose to create. So let's step back for a couple of minutes and take a look at a couple of Transact SQL features that we can use with or without logic. First thing I'd like to take a look at is the @row count system variable. What @row count does is it returns the number of records impacted by an insert, an update, a delete, or even a select statement. So oftentimes you might like to come back and take a look at how many records based on an update were updated or based on a delete were deleted. Now we as users can type in a delete statement, execute it, and the Query Analyzer or the Management Studio will come back in and tell us on the screen, but that's not included within any kind of a data set that's returned back to the user. What if or back to the program that we might write on the backside? What if our program needs to know how many rows were actually deleted or updated? We can use the @row count to get that back. And the way that it works is, once we issue our delete statement or our update statement or whatever the statement is, if we come back in and issue a select @row count and give it a header, in the example I have on the screen here, it says records deleted, it will actually tell me how many records were impacted by the most immediate command. And again, it's got to be the most immediate command that was just issued. Let's take a look. By default, when you insert, update, or delete, nothing's sent back to the calling application that indicates whether or not a command was successful. So one technique we can use to rectify that problem is the @row count system variable. If you return @row count immediately after you do a SQL command, including a select, which is probably not necessary, you'll get the number of records impacted by that command. So let's take a look here. I've got SQL booted up here. What I'd like to do is create a very simple script. So let's do a select into, I'm going to call it TMP, a temp table. So in fact, I'll just call it TMP table. And I want to grab, let's see, everything from master. And let's just try not to grab every record out there. Let's be a little nice on the system here. And we're going to say where birth country equals USA. Try that again. There we go. Okay. So I'm going to create a temporary table, and as soon as that temporary table is done, in fact, let's just do it line by line, just as easy. So I execute it. Now I've got a temporary table in memory. It's got 15,812 rows, and if I wanted to, I can, and temporary tables don't show up in our table list. So if I want to prove that it's there, though, I could say I want to select all records from temp table. And there's all the records that are in temp table right now. So this table only persists during the time that I have my SQL Server up and running. As soon as I close out SQL Server Management Studio, there's a sweeper program. I've seen it take as long as 20 minutes before the temporary table is actually removed, but they are removed. So we've got the temporary table there. What I'd like to do now is let's go back out and find out how many people were born in Washington. So let's select all the records from temp table where, and let's say birth state is equal to Washington. And here we go. So it's telling me now that I've got 105 records looking down here at the bottom right of the screen. And what I'd like to do now is go back in and delete those records out and just see what ends up happening when I delete them. So I'm going to say delete from, oops, I had the from there. But as soon as I do that, I think I'd like to also know how many records are going to be deleted. I expect it will come back and tell me 185. Let's prove that. So I'm going to do a select at, in this case it's going to be row count. And that's all I have to do. So let's go ahead and check these. It says it's going to work, and let's see what's returned back. Oh, you know, and I think I have to put a column header here. Let me just try that anyway. I think I need to put down rows deleted here. See if that works. Says it did. Let's execute it. And there we go. Rows deleted, 185. Now the difference is I can look down here at the bottom right hand of the screen and see it. but that doesn't mean my program on the other end can see it. How do I get that number to my calling program? Just like this. I return it as a data set back, and it tells me exactly how many rows were completed. So row count is very powerful, and it's not just used for deleting. You can find out how many rows when you issue an update, or if you're inserting from another table, how many records were entered, and you can actually do this. I believe I did this once before. There you go. 185 records, 185. There must be a null in here because it says there's 186 returned, but 185 deleted. It says deleted. Obviously, it wasn't deleting those records. It was just telling me how many rows that it returned back. Exists is a really powerful Transact SQL method that we can utilize in a variety of different ways. It tends to return a true when a statement passed to it has rows or information within it. On the example that we have on the screen here, notice what it's doing. If there are records from a select star from members where state equals Idaho, so if there's any Idaho members, then it returns back there are Idaho members as a result within a data set. Else it returns back select there are no Idaho members. So again, exists is very powerful in this form because it looks to see if any data at all had been returned back. Let's take a look at an example of exists in action. To demonstrate the exists statement, I think what I'd like to do is create a simple store procedure, and what we'll do is we'll pass a state in and we'll just simply try to determine if that player exists from that particular state. Now keep in mind that the statement exists is a very closely related statement to the in statement. In fact, you can do a lot of the same common things between exists and in. One of the big things about exists, though, is it looks to see if a null is returned. If a null is returned in the statement, then it doesn't exist. But if anything other than a null is returned, then that does exist. So I think in this case, let's go ahead and create a procedure. And we'll call it SP player state exists. Let's see, I think I'm going to pass into it a state, and we'll make that a varchar state. Varchar, and 2 characters in our state. And of course we do the as to tell it here comes the statement. And then let's do this. If select player ID from master where, and let's do burst state, is equal to at state. So we're looking to see, oh, and I forgot my most important statement here is exists. So we're looking to see, does this return back a null? If no records match a particular state passed in, we get a null and it doesn't exist. But if anything other than the null is returned, then exist is true and it will perform the next statement. So we'll just simply say if it's true, let's select yes, and we'll have it have a title of exists. And since exist is a reserved word, I'm going to go ahead and put brackets around it, or apostrophes would have worked as well. Else, we'll tell it to print select no exists. So simple statement. Here we execute SP player state exists, we pass a state in, we run a select statement, we're looking for any field within that, and player ID is the most obvious field. So select player ID from master where the burst state is equal to whatever we pass in. I could have easily passed over here burst state as well. If it returns back any records, then it's going to come back and give me output that says yes in an exists column. Otherwise, it's going to come back and give me no in an exists column. Let's check this. Says it worked. Let's execute it. Says it worked. Let's grab the statement, copy it, Open up a new query window. Wait for it to give me paste, and let's put in Washington at first. Execute it. Exists, yes. Let's try Alaska, AK. I imagine over the years just about every state has people. Let's try Wyoming. Yes. Let's try some state like YY that we know does not exist. No. So that shows how it's working. And again, very simple statement. I could have gone back in there and used an in statement and asked, if this particular field is in this statement, I could have looked for Washington. I could have produced the same kind of output, but exists as a nice, clean little statement to use now and then. Let's take a look at the in method. I believe we briefly looked at this in the ANSI SQL class, but otherwise we're going to review it anyway. The in statement is used to simplify otherwise complicated OR logic. There are two common formats for the in statement: embedded literal values or the result of a select statement. Let's look at the first example. I want a list of customers' names that come from a state that charges no sales tax. The select parentheses run first, grabbing the table of all states with a tax of 0. Next, we run an outer select that selects all customers whose state is in that list that we generated. This statement is ideal when the states charging sales tax change periodically. Here are two literal examples where the data is already filled in for us. Imagine the where logic that this saves. We would otherwise have to write out where state equals Oregon, or state equals Montana, or state equals blah, blah, blah. You get the point. Also, that second example now inverts the logic from the first. So in this particular case, it's going to give us all customers who are not in Oregon, Montana, Alaska, New Hampshire, or Delaware, those states that don't charge sales tax. In my previous demonstration, I talked a little bit about the in statement and compared that to what we were looking at before in the exists. And we looked at the in statement briefly in the CIS 126 class, but let's just take a moment and go back in and look at it, just refresh our memories about it. So what I could do is let's go back in and decide I'm going to create a select statement, and I want only those players that were born in Northwest states returned back in. So let's do this. Let's do a select. Keep it simple here. So select all records from master where, and let's do birth state. So I could say where birth state, B-I-R-T-H-S-T-A-T-E, is equal to, and I could say Washington, and as painful it is, birth state equals Oregon, or in fact I can't use an and, I'm going to use an or birth state equals Oregon, or birth state equals Idaho, or birth state equals Washington, whatever. The problem is that's going to be pretty lengthy. So a couple of things I can do here. I could do something like this. I could say where birth state in, and in parentheses here, I will just list out those states. It really simplifies logic. So I can say Washington, Oregon, perhaps. Let's include Alaska. And Idaho. I think we got it there. Now I want all records returned from master where the birth state is in Washington, Oregon, Alaska, or Idaho. And let's go ahead and check and see how that looks. And in fact, if I look at my birth state, I'm only going to get my Northwest birth states out. Much easier than having to write that statement out with complete logic over and over again. Now, in addition to this, I can come back in and I could put a where statement in here and return back. It's going to return back a single column. In this case, it's going to return back some kind of a state column. But let's say I want all those people that were, boy, this is a tougher one in here, that were, well, let me just give you an example of what I can do here. I want to select all the states, so I want birth state from master. Let me reach for one here where players' weights are greater than 200 pounds. So I only want those states, then let's go back in, and in fact I have all records coming back in, but I only want it to list out the states where we have players. In fact, let's go make it a little bit smaller. Players that have over 220 pounds of weight. So it's going to grab those states out, and let's make that, obviously, speed it up with distinct, although it's not necessary. And let's check that guy. Says it worked, and let's go ahead and execute him. And in fact, if we go back in there, we'd have to run a statement, but these are all the states. And I'm going to imagine, say there's quite a few of them there where the players are greater than 220 pounds. So it just grabbed out, again, a single column here, which had to match. Now, it didn't have to match the exact column name, but the data has to match the data over here. Loops in SQL Server are not as prevalent as the conditional statements, the if, then, else's, or the case statements. SQL is designed to return rows, but has no specific pointer to point to one record at a time. Although it is outside the scope of this class or an introduction lecture class, you do have the ability to step through rows if you use a Transact SQL cursor. On the C# or VB side of data, we can use a binding source or a binding source navigator to manage a cursor. You saw one of those in the advanced C# class when you used grids and discovered how to use the binding source navigator and to add or remove or thumb through data. But that's, again, another focus for another time. Looping structures operate very much like if-then. We can have a loop run while a result tests to true. I don't use loops as much in Transact SQL myself. I tend to use cursors a little bit more often. In this example, we're categorizing our employees' sales ranges by how much they sell up to 10,000 in ranges of 1,000. For example, we might have 10 people selling $0 to $1,000 worth of products, and we might have 6 people selling $1,001 to $2,000 worth of product, and someone selling $2,001 to $3,000 worth of products, and we want to categorize all those. The data is not displayed, but we're going to store it in a temporary table called table sales range, and then we'll display the table sales range at the end. So let's take a look at the coding on this. The first thing I do is I declare @sales as a real data type so that I allow for decimals to be in it. I then set the sales initially to 0, and then I create a temporary table called table sales range, and table sales range will include the sales and the number of individuals that have within that range. I have my loop here. While the sales are less than 10,000, I want to select @sales the count of where the sales are within that particular range. So, for example, the first range we would start at is 0. It's got to be greater than 0 and less than 1,000. The next time it would loop through, it would then increment that by 1,000 each time. But notice what I do here. I'm selecting the count of those, and then I'm storing that to @sales, that variable we had created. And then I'm turning around and I'm inserting into that table sales range, that temporary table, that sale and then the number of individuals that had that. And we loop back through that every time. Every single time I'm going back in and incrementing @sales by 1,000. At some point when I increment those sales, it's going to jump to 11,000. And at 11,000, it's going to jump out of that loop because, again, the loop @sales less than 10,000 will fail. And then the next line down, after it jumps out of that while loop, it then prints to the screen or into whatever the data set is, all those fields that we just created in the table sales range temporary table, and then immediately we drop that table after it's produced back to the screen. Let's take a look at a working example of a loop. So let's take a look at an example of a looping structure, and to save you a little bit of the pain of having to watch me type all this in, I went ahead and entered it in advance. So let's go through the code and we'll take a look at how it runs. First thing is I want to create a script. In this case, it's the script I haven't saved as a store procedure. I want to create a script that allows me to go back in and grab all of the players out of the master table and categorize them by weight. So I want to start at 100 pounds and go all the way up to 350 pounds, greater than or equal to. And I want to know how many 100 to 199, excuse me, how many 100 to 109 pound players were there, and work up every group of 10. So let's go through and take a look at how I did that, and we're going to run it and see what it does. Oh, and by the way, at the very end of it, what I'd like to also do is print out a graph that shows a little bit about how that respective weight is applied across the board. And I think it's a pretty interesting graph that pops up. Let's take a look at it. So the first thing I do is I create my starting weight, and I want to start it off at 100 pounds. I could start this maybe at 150, but I want to start it at players that weigh 100 pounds, and then we're going to increment it up from there. I have another variable I'm going to use called my weight count, and it's going to be of type integer as well. I'm creating a temporary table, and that temporary table is called range, and the range is going to have the starting range and then the number of people that are within that range. So for example, the first time through, it's going to store 100 in the first one and then count how many players were within 100 to 109 pounds. So again, I have a at start, as long as at start is less than or equal to 350, at start is 100. So here's my loop right here that's going to run through, and every time I'm going to increment at start by 10. So it's going to start off at 100, 110. When it gets up to 360, it's going to then jump out of the loop entirely and come back down and replicate the information. So let's again take a look here at the loop. Notice I have to have a beginning and end in this case. Why? Because I have multiple statements in here that have to be treated as part of that loop. So it's going to require a begin and end. So first thing I want to do is I want to find out how many players are within that start and end range. So I start at 100 and I add up to 10 and I ask how many are in there, and I probably should change that to 9. Okay, so first one is count the players where the weight is 100 to 109 and the date of death is null and the final game is null. So we only want current players that are playing, or at least those identified as current players. As soon as I get that count, how many are within that range, I add that to the table, the starting number, first time through 100, and then how many people had it. And then I increment at start by 10, and it loops back up, and it says, is at start still less than 350? Yes, it is. So at that point, it would be 20, and then it loops down through 20, 30, 40, 50, etc. And then I have it print out a graph at the very bottom. Let's take a look and see what this guy's going to look like here. We check it. And by the way, we're going to come back and look at this replicate here in just a second. Replicate is a string method that's available, and what we're doing is we're replicating a star, whatever weight count was returned back, divided by 10. And let's see what we end up with here. So let's check it. Again, it says it worked, and let's run it. And here we go. So notice that coming down here, I've got 1, 110, 120 all the way down. Nobody fell within that range, but it's very interesting to take a look at the weight distribution that we have within baseball here, and that came right here from this guy, right here. And it's interesting, look at that. It tells you that baseball is pretty evenly distributed as far as that bell curve goes, but I've got the starting weight, and the only thing that allowed me to do that, by the way, was this loop right here. It let me keep looping through it and picking those numbers out and then adding a row. And what I did was at the very bottom here, I selected this table. So what printed this out right here? So you remember I created the temporary table here, and now I come back in and I'm reading from range, which is that temporary table right here. And this is entirely stored in that temporary table. And what am I getting? I'm getting back all the fields that were in here, starting number, the number of players within it, and then at the very end of that, I'm saying also add in a replicate an asterisk for whatever the number returned, 32, so that would be 3 divided by 10, or it's as an integer, so 3, and it's going to give me 3 stars out here, and I simply call that graph, and that's where this came from. It's kind of a way of simulating a graph within SQL on the screen. You're probably not going to want to do this normally. You're going to have an application on the other end that's going to create a nice, really formatted graph for you, but this does give you a look at your data. The last statement that we're going to take a look at that is common in Transact SQL is the print statement. As programmers, we're not going to use the print statement much because it's not sent to a data set that we as programmers can use. The results of the print go to a message window rather than the results window that we expect. But we can use the print statement more often to do debugging. Here's an example of the print statement. If there exists members from Idaho, it's simply going to print then there are Idaho members. Otherwise, it's going to print that there are no Idaho members. Let's take a look at a working example of this with the understanding, though, that we're going to use this more often to have periodic printout come up so we can use it as a debugger because it's not at all going to be usable to send back information to the client on the other end. This last demo that I'd like to show you will be the print statement. Now, the print statement is very similar to select, except that the print statement is not something that we as programmers can use to get data back. What do I mean by that? Information from the print statement doesn't go to the results window. You look down here, we have a results window from that previous example that we looked at. This is the results window that would be returned to the program on the other end as a data set. But information that comes from a print statement does not come back into the results window. So we typically will use it as a debugger to go back in and watch maybe a store procedure run and see what values are. Here's a very good example of that. Let's say that I'd like to go back into this store procedure and watch the value of @start as it goes along just to make sure that it's incrementing correctly. What I could do is come back in here and simply put in a print statement, and at this point I want to print @start. I like to see what @start is as it's looping through. So let's check it. It says it worked okay, and now let's execute. Now notice that when it executed, I got the results back, and here's my same results window. But if I go to the messages window now, what I'm seeing is the results of all those values as they step through. My program on the other end is not going to see it, but it does allow me to go back in and look at values that I might want to progress through and debug a little bit. So it's a nice little feature built in for that, although we're going to also find out later that when we're using Visual Studio, one of the things that we can do is actually step through a program later with a debugger, and it's going to be even more powerful than the print statement. But if I was to delete this out and simply come back in and say I want to print my name, and then let's do a select my name and execute them both, what you're going to find, and let's get it to come, is that I've got my, of course I didn't put a column header after it, it's warning me here, but in both cases I have Tom printed out. This is the only one that would be retrievable by a program on the other end. So again, debugging works nice at this point in time, but later we'll go back in and learn some more powerful debuggers, and Visual Studio now is increasingly adding a lot more debugging features for stored procedures into it. This is the completion of my 3-part series on the basics of Transact SQL. There's a lot more to learn. I could have spent days on any single topic that we've covered here. What Transact SQL can do is immense. You can expect that I'll also be adding some additional topics as time goes on, including transactions and cursors.